All right, our parameter is from 0 to pi, which it's perfectly fine if we just did 0 to 180 instead if you prefer degrees, because t isn't even part of our graph, so that doesn't matter at all. All that matters is what our x and y values are. So we're going to plug in 0, because that's our starting value, and we're going to go up to pi, or 180, and then just go with some numbers in between there. So maybe 90 here, and maybe 45, and 135, or something like that. Let's see if those values give us some good numbers. We're going to need to know what the answers are. And the cool thing is we're doing cosecant, which is the reciprocal of sine. So once we found the x values for sine, all we have to do is find the reciprocals to find the y values for cosecant. All right, so the sine of 0 is 0, and the reciprocal of 0 is undefined. And then sure. And then the sine of 45 degrees is square root of 2 over 2. And square root of 2 over 2 simplifies to 0.7, doesn't it? Is your calculator in radians or degrees? Okay. And then if we do the reciprocal of 0.7, so that would be like square root of 2, right? Because square root of 2 over 2 and square root of 2 are reciprocals. So square root of 2 is like 1. Yeah. Okay, and then 90, the sine of 90 is 1, and the reciprocal of 1 is 1. The sine of 135, all students take calculus, it's still positive. In the second quadrant, it's the same reference angle, so it's another square root of 2 over 2. And the reciprocal of that is another square root of 2. And then 180, sine of 180 is 0, and so the cosecant is undefined. Okay, let's see what this graph is going to look like. Oops. Again, all of our numbers are positive. So I'm just focusing on the first quadrant, and I'm going to count by 4s again. We're kind of used to doing that at this point. So 1, 2, 1, 2. That should work. And let's graph. So 0 undefined. Oh, we can't graph that. All right, we're going to have to see what that's going to look like when we get the other points in there. Okay, let's do 0.7 comma 1.4. So 0.7 would be about here, and 1.4 would be around here. So somewhere in there, correct? Then we have 1, 1. Whew, that one's easier. So far we've moved from some point 0, some point undefined here where we can't see it because it's going to infinity. And then that's moved down this way to this point, and then it's gotten to the point 1. But then what happens after that? What happens to our sine graph, after it reaches the top at 1? What happens to those sine values? They immediately turn and go the other direction, right? So that means that this is the end of the road. The graph is going to come down to that point and then bounce back the other direction. So we might want to plug in another point in here just to have another point in there, like maybe 30 degrees wouldn't be a bad idea just to have another point. So 0.5, and then the reciprocal of 0.5 is 2. So 30 degrees, so the 30 doesn't go on the graph, it's the 0.5 that goes on the graph, and then the 2. So we're going to have a point like there. So see, that shows me that it's sort of a little bit curved. That's what I wanted to know. It's going to come down to this point and bounce back. So that is going to infinity, to positive infinity. And it starts there, but then it comes downward and goes back. So we actually have arrows going back both directions because the object is moving both directions on the graph. So it's hard to indicate just with arrows that it's starting at positive infinity, coming down to +1, and then going back to positive infinity. It really is, and it doesn't help that my pen makes it hard to draw the lines so that they look halfway decent.